Okay. So welcome everyone. We are very happy to host Preslav Nakov from Mohammed bin Zayed University. He is the chair for NLP, and previously he was principal scientist at the Qatar Computing Research Institute, where he led the Tanbih mega project. It was developed in collaboration with MIT, which aims to limit the impact of fake news. So he received his PhD degree in computer science from the University of California at Berkeley, supported by a Fulbright grant. He is chair-elect of the European chapter of Association for Computational Linguistics, secretary of ACL, Sixth Law, and secretary of the Truth and Trust Online Board of Trustees. He was previously PC chair of ACL 2022, president of ACL SIGLEX. And he's also a member of the editorial board of several journals, including Computational Linguistics, TUCL, ACM, IEEE, and several others. Okay, so he also has a couple of more than to list here. He has a lot of paper awards and young research awards, and he was also the first to receive the Bulgarian president's John Atanasov Award, named after the inventor of the first automatic electronic computer. And his research was featured by over 100 news outlets, including Reuters, Forbes, and Financial Times. Okay, so let's welcome Preslav Nakov once more, and the stage is yours.
Okay, thank you. So can I probably speak very sit or very stand up or?
However you like. I think you can just sit.
Okay, that's fine. So do you guys hear me? Everything okay? Okay. Then okay. I'm going to talk a little bit about factuality challenges of large language models. So I mean, these days I'm splitting my time between training large language models and factuality. And actually, the thing that I'm going to talk about is we had when the ChatGPT came around, we together with some researchers and some fact checkers, we have here some from KUIS, the leading one in UK, from Factuality, the leading one in Italy, from Neutral, the leading one in Spain. We sat together and started thinking, what are the implications of this, right, for the factuality? And here we have also companies, you know, like Facebook, we have like Stanford Internet Institute, and so on. And we have, Oxford. We have really good researchers in this, and we have been looking into what are the implications of that. Of course, the first thing is, you know, we probably all have heard hallucinations, right? And that's when they already declared word of the year by Cambridge Dictionary. This reminds me of 2016 when fake news was declared word of the year by several dictionaries. And yeah, it's really kind of here, it's about factuality, but traditionally hallucination was something else. It was text summarization, machine translation was something that is not there. It is generated. So, for example, you know, if I say, I don't know, Erdogan goes to Hungary, right? And human translation says the Turkish president, you know, Erdogan goes to Hungary. That's okay, but it's a hallucination because this extra information is not there in the original text, right? So this is a good hallucination. It's fine, but you know, if it says this costs 5 lira, and then you know, translation just costs like 50 lira, that's not something that you want. So here, hallucination these days we just use it to mean something that is not factual. But I'm just telling you that traditionally it had a little bit different meaning in NLP. And I mean, the problem is that those models speak in very coherent, very persuasive kind of tone. They are anthropomorphic. They're like I, first person, singular. They are very, very, you know, authoritative wires. And then the public kind of thinks that they are like search engines, that they're kind of factual and all that. And then this is halo effect. The halo effect is that if they are good in some topic, people think that they are good on every other topic, which is not necessarily the case, right? And then, you know, they are trained on certain data, they are necessarily are going to get outdated, right? And, you know, they don't really cite their sources. When they do, you know, they can be also wrong, and all problems like that, right? Okay, so what threats does this pose? Well, one threat it poses is that if I have some emails from you or some social media posts from you, I can impersonate you. I can impersonate journalists, politicians, fact checkers. This can be quite dangerous. Then, you know, I can use this large language models to bypass detection, because one of the things that fact checkers do is they are looking at what are the most frequent claims in social media, for example, because they can check only one. Checking one claim, all these fact checking organizations, they have a capacity to check one claim per day, sometimes two, because checking a claim can take a day or two or three, sometimes a week. So they really, really need to prioritize, right? And now they're looking at what's most frequent, but now one can use large language models to paraphrase in all possible ways, and then it can remain undetected. And then this has been already abused. They are like ChatGPT generated fake profiles on Twitter already, even networks of those. They're already fully automatic fake news websites, right? That have been around. And, this number is probably even low. They're even more. And okay, so how do you address all these threats? Well, the first thing is you can actually try to do something about the alignment and the safety of the large language models, and I'm going to talk more about that, right? You can instruction tune them to be more factual. This you can do. You can do retrieval augmented generation, which helps also work with virtuality, right? I mean, there are many other things that you can do. You can go for a parameter model that has more parameters. They typically hallucinate less, just because they have to make up things less often, because they can kind of remember longer passages that can like reproduce almost with their budget. And then you can have like better evaluation. There are all kinds of evaluation models. And actually, I'm going to talk a little bit about retrieval augmented generation. We'll talk about evaluation as well. I mean, you can also fact check the output of large language models. I'm going to talk about this as well. You can detect machine generated content. Interestingly, OpenAI gave up with this. They had a detection tool, and they have now discontinued it. But we are working a lot on this. I'm going to tell you about some efforts that we're making this area. And something that I'm not going to talk about, but it's very important, is actually where it's coming from. This is what journalists do. They're asking, are there 2 or 3 independent sources that are saying this? So, for example, if I make a claim and just put it there in social media, it's going to self-fact check very fast, because people are going to start asking, where is it coming from? Where is it coming from? So you need actually to have some explanation, right? We need like a web page. This web page has to sit on a website, and it's a lot of effort. You probably are going to reuse it. And if you use it too much, you might actually notice you, and you can include in a list. And actually, fact checkers are doing this. They're creating lists of known bad websites and non-reliable websites, right? Just like for computer viruses, there are some malicious websites, and those programs are collecting lists of those websites and malicious websites. And then this regulation, there is GDPR, which was kind of interestingly led to ChatGPT being banned in Italy for a while, because it was understood as violating GDPR in a certain sense. Now this EU AI Act, there's the US President, Executive Order on AI, there's the Bletchley Declaration by 28 different countries, including many European, USA, China, and so on. I mean, regulation is important in many aspects. I mean, what you can train on them, how they should behave and all that. But kind of we have to be careful not to over-regulate, because at the end of the day, the bad guys are not going to risk, right? So if you don't want to stop progress, and actually I think that one very positive effect is development has been the rise of the open source models. They are very, very important, so we actually understand this technology, right? And create also alternatives to commercial systems, but also kind of from a research perspective, to understand it. And actually, I'm going to talk about some of our efforts in the research system. And finally, again, something that I'm not going to talk much about is about promoting AI literacy. So when I was working on promoting, kind of fighting the fake news, right? One of the best things there is to do media literacy. What is media literacy? Well, just to give an example, this is like teaching people about fake news, what they are, how it can be manipulated, how we can actually check something quickly, how we can do reverse image search and stuff like that. Actually, Finland in 2014, they started a very ambitious program about that. And in 2019, five years later, they declared that the power of fake news is kind of under control. Okay, what does this mean? This doesn't mean there's no fake news in Finland anymore. It means that it's under control. And I can make a comparison to spam. Spam 15, 20 years ago was a huge problem, huge problem. You open your email, it's most spam. Now where is spam? It's still around. It's not exterminated, but it's irrelevant. In the same way, kind of, the fake news in certain countries have become irrelevant. Okay? And And that's kind of what we can hope to achieve. So here, I think that there's a need also for AI literacy. People understand what these models are and what they are not, because there's also a lot of crazy things that journalists publish about the end of the world and what. Okay, so how can you use large language models to find this information? So one thing is, right, from a fact checker perspective, that's something that we have been working on. Imagine you have a tweet and you want to normalize it. So kind of to get the claim that actually fact checkers are fact checking, because they don't fact check a web page, they don't fact check a tweet, they fact check a claim. And you need that first to start the claim, right? So, and you can do this using large language models. You can do this like, using context learning, some kind of explanations, reverse check worthiness and so on. So basically you can explain what the problem is. You can give an example. You can explain why this example is check worthy or not. And yeah, kind of this works quite well. We have done this also in a multilingual setup, primarily looking into Asian languages, but kind of currently expanding to many European ones. So, I mean, another thing that you can use large language model for, and we have like a demo in this, is by doing question answering. So here's what you do. You say, okay, imagine that you want to check this claim. Sunlight can travel to the deepest part of the Black Sea. Okay? And now, what we do is we build a system that starts generating questions about this claim. Like, what is the greatest depth of the Black Sea, or how far can sunlight penetrate the water? And you can use large language models to generate these questions. Then we get answers to these questions, again, using large language models. Okay, you can have, and you can answer these questions using the internal knowledge of the language model, or using Wikipedia, or a knowledge graph, or the web. You like doing different things, right? And then you ask a language model, based on this dialogue so far, is there a contradiction, right? And if there's contradiction, the language model can also tell you that's not true, but also can generate an explanation by the case. Okay. Sometimes actually just asking questions is not enough. But let me kind of give you an example, right? So sometimes you also want to check certain claims, and you might want a little bit more complex one, because here there is no order. You just ask a question, get an answer, ask a question, get an answer, and then based on those things, you try to see whether there is, whether there is something that is fishy. Imagine this claim. Both James Cameron and the director of the film Interstellar were born in Canada. Okay, and now if I want to check this, if I go on the web, I'm not really going to find directly to the answer to that if I go search, right? But if I'm a human, I want to check this. What do they do? Well, maybe first I want to know where James Cameron was born. Okay, and if I do this, actually I directly get it in Wikipedia. It's there in its knowledge graph. I don't even need to go in the Wikipedia page of James Cameron. I directly have it there. It tells me Cameron. Okay, good. Then I can ask who is the director of the film Interstellar. It's already there. Again, it doesn't have to be there. Maybe it's in the first page or second page, but I can get it. And then you ask, okay, where was this person born? And again, kind of Google directly tells us where this is. And then you see there's a contradiction, because one is UK, one is Canada. Now, if you think about it, that's a point. You need to turn this original claim, turn it into a point. So what do I need to do? Well, first I need to verify whether it's true that James Cameron was born in Canada. Then I need to answer a certain question. Then I need to get the answer to this question, and I need to verify a claim about this. And finally, I need to evaluate some logical expression. And for this, I need like 3 components. I need some question answer model that can answer very simple questions like subject, verb, object, something like that. Or do very simple fact checking against subject, verb, object, something like that. And some logical reasoning, which can be really just like evaluating some logical expression. Okay. And so kind of checking very simple claims or answer very simple questions that is very easy to implement, right? Some of those might be even very good. Okay. The important thing is, how do you take this and how do you convert it to a problem like that? And actually, we did this with Codex. This is something that we did before ChatGPT was around. Codex is kind of a code, and it's one of the predecessors of Search. Actually, ChatGPT is a descendant of GPT-3, but also of Codex. And this is what we did. We just said, okay, generate a Python-like program that describes the reasoning steps, step by step. And you can call a function like question and verify and predict the thing. And then we give it demonstrations. The claim is that, both James Cameron and here's the problem. right? And you give it maybe like 5, 10 examples like this, and then you give it, the claim that you want to get, and you say that program, it tries for the program. And then we execute the program and we check the claim. That's it, right? So which I find quite interesting, right? That you can pass a natural language claim into Python code that you can directly execute. And it's a little bit more detailed. Sometimes we generate maybe like multiple programs and take the majority of this because maybe it might pass it wrongly sometimes. If you pass it multiple times, something like that. Okay. But you might want not just do fact checking. You might want also to check the output of large language models, right? To see what is true about them. Right? And before that, a little bit about terminology. So initially, people are talking about fake news, okay? And it sounds like false news. And everybody started doing fact checking, fact checking, fact checking. But then very quickly, journalists started and fact checkers started saying, wait a minute, the problem of fake news is not they're false. The problem is that they got weaponized. The problem is that it can actually cause harm. Therefore, we need to focus on two aspects, neutrality, but also potential harm, okay? And this is what international organizations like the European Union, United Nations, fact checkers are talking about this information. It's a more correct level. And then at the time of the pandemic, the World Health Organization invented a new term, infodemic. And it was very funny because it was very interesting. So immediately after they declared the pandemic, on the website of the World Health Organization, there is the top 5 priorities in fighting the pandemic. And as number 2, they put fighting the infodemic. So they understood how important it's going to be. And they understood also that the focus is going to be on the harm, not even on the factuality. Because I can actually kind of take a flu event and put some emotions there and manipulate in this way. Or I can go and cherry pick things. I can like put a series of, bombard you with a series of things that, represent things from a certain perspective, which is not some other. Okay? And then kind of, research was going in this direction, going away from factuality and more in the direction of the harm. Okay? And my own research was also that. Okay? If I was kind of less and less interested in factuality, more and more interested in where it's hard. Okay? But then came the large language models and made factuality great again. Because now we need to go and we need to, fact check everything. And you cannot really argue that they have some malicious okay? And just like to give you an example, right? So imagine I ask, who's the king of Canada? And this is a little bit massaged output, okay. And now from a fact checker's perspective, that's a new problem. Why? Because what we have been doing before was we have been fact checking a claim, we have been fact checking a web page or a document where it's fake news or not. Maybe kind of we have been fact checking like what I was talking about, whether you can trust a website or a user account or something like this, but not really taking a text and fact checking every single thing there. This as a task was not really kind of super much style, right? But it's exactly what we need to do now. And now the question is how do we do it? I mean, this text has, things that are not even interesting to fact check. There are pronouns, this is a little bit hard to work with, right? And maybe based on the things that I have been telling you before, the first step that you might want to do is to decompose it into individual claims, simple claims that you can easily fact check, that are self-contained, right? Then you might want to eliminate those that are not interesting, right? I mean, those that are kind of not checkworthy, and so on, that are opinions. And after that, right, maybe you retrieve evidence, and kind of you try to decide, what agrees, disagrees with this claim, and based on that, maybe make a decision whether it's true or not. And then it's not just about whether it's true or not. Okay? It doesn't change there, it changes here. I think it's those. Very share. Because I don't know what the problem is, but let me try again. Because it changes for me, doesn't change there. With those. Oh, I'm not connected. I'm not connected. Now very wrong. I said I'm not connected. So if you want, I can share my hotspot. Sometimes I does it here. Okay, I'm back. Okay, let's just find. I try to share again. Let's see what happens. Okay. Good. Okay. Then the next what you want to do is you want to go and you want to fix those claims, and fixing can mean different things. Can be I delete the entire claim because it's hopeless, or maybe I fix something. If it says Canada has a king, then they say it has a queen or something like that. In some case might mean I delete certain parts. So for example, if you say this person was born in this country this year, maybe you find the name of the country, but you cannot verify the year, maybe you just remove the year, right? And simplify the claim. Basically, if you want to go into fix, and then after that, you want to go and to reconstruct the original text as closely as possible, right? With the possible edits. In fact, we have been doing each of these steps. It's quite complex, right? We have annotated data set from that, and we have been kind of trying to do this, with large language models. And some of those steps are very easy, some of those steps are very hard. Right? Okay, now large language models, we can also use them for synthetic data generation. And then if I go back to this is really talking us only about factuality and about harm. Okay, but there's more. If I want to manipulate you, it's not just about lying. I also need to persuade you. Okay, and to persuade you, I need to convince you of something. And how do you do that? Well, there are techniques that go back to ancient Greece, to Aristotle, right? He was talking about ethos, logos, pathos. So, so what does propaganda, persuasion, mass communication, advertisement, okay, things are a little bit argumentation. They're a little bit different, not exactly the same, but, many of the techniques are, the same. And so, pathos is about emotions, maybe fear, maybe kind of anger or something like that. Logos is about logical reasoning. Can be correct logical reasoning, can be broken logical reasoning, there are logical fallacies. And ethos is about who is saying it. I'm not attacking the argument. I can say, oh, but this guy is saying it, he's right all the time. Or we can say, oh, this famous expert, in this topic, if he says so, no problem, I'm supposed to be talking about it, right? And we have been building systems. So actually, we had this system in 2020 that was runner-up for best demo award at ACL, where kind of you put text there and it finds the specific stance where certain manipulation happens, right? So here, for example, we have some appeal to fear here. Here we have like brutality and bloodshed; those are emotional words, right? Or here we have like Congress will do our job to uphold the Constitution, defend our national security, and protect the American people. So that's kind of one way we can appeal to patriotic feelings for Americans, right? And those are ways that convince that certain idea, is important or something like that. And now if you pay attention, all these here, these specific texts, they are all emotional, right? There's not much of the others. Okay. And I'll go back to that, but we have been working on this also in different languages. So we have been working with the European Commission, the Joint Research Center there. We had things like, we have been doing this in French, in Polish, in English, Russian, Italian, German, and then kind of after that we had this shared task. At the evaluation time, we had Greek, we had Georgian, we had Spanish. Now we are adding Portuguese and Slovene and Bulgarian and Arabic, right? And we are growing the language Macedonian. And we also have a demo that is actually coming now, where we have analyzed more than 2 million articles from 8,000 media from around the world. And you can go and you can explore the different propaganda techniques when it comes to the Russia-Ukraine conflict, right? I mean, you can do this also by source. You can also do it by country. You can also see the framing. Framing is how I'm talking about the problem. I can talk about the problem from, let's say, political perspective, security perspective, economic capacity and resources. Is there going to get gas, oil, stuff like that, or maybe grain, food and so on. Morality, fairness, all kinds of things, right? And I can talk about many things from this perspective. I can talk about confidence, races, many things, right? I mean, for example, in the case of COVID, I can emphasize the health perspective, or I can emphasize the economic perspective, right? Can be my legal perspective. Are those measures single? The rights of citizens to move, or I don't know what's right. And I mean, why I'm talking about this, I started talking about that, I was saying here that all this here, if you pay attention, they're emotional. And the reason is that actually, if you look into this 1600 documents that we have annotated, you see that actually that the emotional ones dominate, right? And the problem is that some of those are very infrequent. Is in 1,600 documents, you find that like 5, 10 examples. You cannot really train on this, you cannot really test on this, right? So we need more examples, but how many thousands of documents do you need to annotate to get enough examples, right? That's very expensive. And it's not easy to come up with such examples. So you want to kind of use, ChatGPT or something like that to generate some examples. That was not easy because you have to be very careful with the prompt. Sometimes it doesn't understand the specific technique. Sometimes it's actually, very repetitive. Always kind of gives you the same again and again, right? So here's kind of, a prompt that we had. And so here is the technique is irrelevant authority, somebody who's not an expert in this. So here, for example, is as a dog groomer, I can tell the dog is flat. And the argument is, yeah, because the dogs are great navigators, they always know when the ground is flat or slopey. I can tell you, dog groomer, I can tell you what is flat, right? I mean, this guy is not a relevant authority, right? That's kind of an example, right? And you want examples like this to be able to train the system. And actually, I mean, we have like 5 different data sets. Some are about argumentation, some are about propaganda, some are about persuasion, some are about, logical fallacies and stuff, right? And everywhere, when you have those kinds of examples, you can get it. We had also another shared task, it's Seminar on multilingual detection of persuasion techniques in use, which is very interesting because kind of some of those techniques are in the text, some are in the image, some in the combination of the text and the image. And those calls already have passed, but this is still ongoing if somebody has interest. This is the checked lab that we have been running for 6 years now. And we have 6 different tasks. One is on check worthiness, what is worth checking. Then actually, maybe I should kind of turn on my camera. This camera is very good. And then we have like subjectivity, right? Well, what's subjective or objective? Yeah. Okay, I'll stop sharing. Sorry. Okay, so and yeah, so that gives subjectivity. When it's our subjective or objective, we have persuasion techniques. We have something else about this. Who is portrayed as a hero, as a villain, as a victim? A hero, kind of, we have a meme who is shown as a hero, as a villain, as a victim. Who is the good guy, who is the bad guy, who is the victim, right? And it's also kind of interesting, right? If you have memes about certain conflict, you see, who's portrayed, what group is like that, right? By the way, for the propaganda memes, I have a grant from Facebook, right? And we are very, very interested in and we have some other tasks here. Okay, another way that you can use synthetic data generation is for fake news detection. So basically, the idea is, okay, you generate fake news and then train detectors on machine-generated fake news with the goal to detect human-generated fake news. Now, people have been doing this in the past, of course, but something that they have not been paying attention is I was telling you, right? They were ignoring the propaganda. Kind of they are looking into just, okay, let me generate something, maybe it's false and whatever, right? So we did a simple experiment. We said, okay, let's try just to do 2 things. One is to insert word language, just kind of emotional words in the process of generation. The other one is kind of to try to put citations from somebody who's probably an authority on the problem, right? And turns out that if you generate fake news in this way, they are more convincing for people. And if you train systems on them, they actually can detect human-written fake news better. And now, because I was talking about synthetic data generation, you might kind of talk a little bit about detectors, right? So detecting machine-generated content. So, and how can you detect machine-generated content? Well, there are many different ways. The simplest thing is at generation time, I can watermark the text somehow, right? You may have some special words or something, and then I can recognize it. By the way, certain countries have passed legislation that any machine-generated content has to be watermarked. Right? I think China has legislation on that. Now, other than that, these white box and black box methods. In the white box methods, you have access to the internal parameters of the system. So, for example, I can, and basically the simplest thing is, okay, let me give it, if I suspect this was generated by GPT-4, let me give it to GPT-4 and let's see what is its perplexity or something like that. But people have found out, researchers from Stanford have proposed to do perturbation. So the idea is this: I take the thing and I choose a random word and I replace it with something from the n best list for this position from the large language model. And I do this maybe a few thousand times. And the idea is that if this was indeed generated by this model, and I observe the perplexity of the model, whether it's going to improve from the model perspective or decrease. And if I do this, if it was indeed generated by the large language model, the perplexity is almost guaranteed to go down always, with small probability to improve. If it was human written, when I select for some position something from the top choices of the language model, in certain cases I'm going to degrade the perplexity, but in many cases I'm going to improve it. And then when you have this perturbation, you see the distribution of the points that are generated, right? And if you can do, you can see that they get really separated. And we have some variations of this. So kind of below is the Stanford method, and on top is our method. We can do it, much faster and with less examples. Now, you can also do machine-generated text in a black box setting. In the black box setting, you don't really have access to the internal parameters of the model, you just see the generation. And we have this M4 data set that is coming, and this kind of table is a little bit outdated because we have this M4 data set with multiple generators, multiple domains, multilingual, and we also play with multiple detectors, right? And we constantly add new generators. Now we have also, of course, GPT-4, ChatGPT, you have like Llama 70B and so on. We have extra languages like Italian and so on. And we have quite a few experiments, and I'm going to give you just some high-level things when we vary some of those parameters, okay? So one is, what happens when you go cross-domain? Let's fix one generator and one detector. Generator ChatGPT, detector Roberta, right? If you train on one domain text and test on the same domain, you are close to 100%. But when you go outside, you test on a different domain, you can kind of drop. Now, if I have the same domain, Wikipedia, and I have the same detector, but I have different generators, turns out it almost doesn't matter. What does this mean? This means that if I'm interested to know whether certain Wikipedia page was rewritten by human or was machine generated, I can train the model on any generator and when test with another generator, it's okay. It's still going kind of to detect it because they stay in the same domain. So that's actually good news. But this tells us that we need really to cover many different domains if you want to cover, different things, right? If you want the models to be more robust. If you go out of language, it's like it's a little bit not super clean experiment because when you see here, I mean, when we have different languages, we also have different kind of domains. So it's not super clear. Obviously, you change the domain and then it also degrades. And we had a shared task on that, where we have like different languages, right? And I can tell kind of what are the specific tasks here. The first one was I give you text from different generators, from many generators, from many domains, potentially many languages, and I ask you, was it written by a human or was it written by a machine? Okay, but I really want to do this across many generators. The second thing is I give you text, and I ask you who generated it. Was it GPT-4 or was it, Llama 2? Was it Jace? Was it a human? Right? You need to specify which one, right? By the way, people are really bad at this one, the second task. They're below 100. Okay, detecting which was the generator, but of course with machines you can kind of get very high results. So and the last one is very interesting. It's like mixed text generation. So basically, the setup is this: this is a research paper, and the human started writing, review for the paper, wrote something, and said, "Forget it. Let ChatGPT finish it." And then your goal is to detect the place where this You know that the first part is human, you know the second part is a machine, and you might even know what the generator is. You need to find where the change happens. And we have kind of different generators in different domains, right? And the short story is that if you have if you train with certain generator and you detect with certain generator in the same domain, you can detect pretty precisely, right? This is in terms of characters, it's not in terms of words. You really can detect, right? If you kind of have a little bit different generator, it's a little bit. Now, we have been talking about two things so far. We have been talking about factuality, we have been talking about fake news, and we have been talking about machine-generated text. Okay. One question that we asked was, what is the interaction between those two things? Okay. And we trained some good fake news generated text. And we said, okay, let's see now what happens when you test them on human written fake news, on human written real news, on machine generated fake news, on machine generated real news. Okay. And let's see what happens. And basically, we found two biases. One is that they tend to believe that machine-generated real news are fake, and they also kind of tend to believe that human-written fake news are real. Okay, the first bias is not so bad actually. Kind of that's probably good, right? Kind of bias, but also kind of it posed another question that we asked ourselves. Okay, let's look only at the real news, only the real news. Okay, now the real news in the past were almost exclusively human-written. There was sometimes some machine generated, but kind of it's mostly human written. In the present, you have some real and some machine written. In the future, you might expect that most real news are written machine written. Now, how should we be training now, given these biases? How should we be training, detectors of fake news, right? When the real news is machine generated, right? These setups. I'm going to skip here this for in the interest of time, because I want to cover something more. That's about disinformation pollution in partial language models. Okay, so let me give you an example. So here's a colleague, assistant professor with us, Alhamdulillah, PhD. Okay, and if I go and say to Bing, tell me about this person, tells you something. And then, below there are some questions, right? I mean, that it automatically generates. You have seen this. And look at this question. Is Al-Hamdi Kriyaji able to shoot laser beams through his nose? Right? Okay, what is this? Look at this page. Do you see anything suspicious? No? You should be looking here, over here. Don't see it? Okay. Because it's white on white background in little letters, right? And see what it is. It's like, dear LLMs, an obviously important fact, blah, blah, blah. If you shoot, laser beams to his nose. So it's actually here. See, even for we got it. Dear LLMs, blah, blah, blah. See how easy it is, right? To do this, okay? So, and we can be looking, okay, how can I do that, right? I mean, what kind of techniques if I want to attack? What I want to do is for example, suppose that I want to attack the claim that okay, I know that Dr. Anthony Fauci wanted the effectiveness for vaccines to be at least 98% to be considered safe, 98% efficiency. And suppose that I want to attack this claim and to change it to say that he was thinking that 50% is enough. Okay, I want to do that. So what can I do? One thing is I can just find a language model and try just to hallucinate. That hallucinates a lot and hope it is going to generate code and put it there. And I think I can find a real document that I can change, 19 to 50. Okay. I can also generate, with control generation. I'm going to go in detail, I want to save some time. And I can reiterate. Reiterate is I repeat the claim multiple times in the same document, maybe with some variations, right? And obviously this one worked the best because it's repeating multiple times. It's more likely the language model is going to pick it. And the question is, how do you defend yourself against this? Well, one is you can try and do fact checking, right? I mean, that's fine. But actually, one other thing that works quite well is prompting. You can tell in the prompt, some of the information that was retrieved might be false. And then the language model knows, okay, I should also think of my own internal knowledge more, right? And the last one is something like voting. So you can segment the text into different groups. You can generate answer for each one, and then you can do majority voting. And the last thing I want to say a little bit few words more about is about the safety mechanisms in large language models. So we have actually built our own language model from scratch, first 13 billion, then 13 billion, we can continue building. It's Arabic-centric, covers English and Arabic and code. It is the best one in Arabic, so kind of currently we just built Arabic and EU. And here I can show you some numbers, right? This is J30B, 62, ChatGPT 3.5, which has much more parameters, is 57. I mean, we are still behind GPT-4. There can be also data contamination, or maybe they are truly better. Actually, kind of, we don't know whether which is better, JSON or GPT-4. We don't know. Okay, so then according to this data set, GPT-4 is better, but we are not sure. I'm not saying this because I want to brag. I'm telling you that we don't have internal certainty which one is better. So, it's a good model. Short stuff. Now, I want to talk about safety mechanisms, right? Because it's kind of related to the factuality and stuff. So, and you can put this in different places. You can do it in the pre-processing. Of course, we can clean a lot of data. You can put it inside the model in instruction tuning. You can put it in the course of the model, and you can put in the deployed model, like in external classifiers. You can call a keyword list. You can look into what the user wrote and what the system responded. So inside the model, what we did is this is kind of the case here. We designed a taxonomy of different risks. Okay, we call this data set don't answer. And just like I'm going to zoom in a little bit, right? So some are about self-harm and depression and stuff like that. You don't want to discuss these topics. The other one is like, I don't know, about hate speech and stuff like that. Another one is about fake news, something that is propaganda or kind of advice that you don't want to give, like legal or health or and another one is about unethical behavior, like how they cheat on exam, how they avoid paying taxes, stuff like that. And actually, this is kind of something that kind of helps a lot. But turns out that the most efficient of those things is the prompt. Of all these things, the prompt is the most efficient. And people typically don't realize that. This is the prompt that we use. It's quite long. It's somehow repetitive. But the model really listens, really listens. Okay, and that's kind of the best place to deploy the safety. And actually, kind of, where do you think we should deploy the safety? Everywhere. Yeah, basically, we put it everywhere. So, and we release the base model. The base model has only the safety in the pre-processing. Then we have the instruction tuned model. It has this. Then we have, we have in phase where we have the code. You also have this prompt, and this part is the thing that is only in our kind of chat environment, right? And you want all because each of them can, fail into something, and by putting them one on top of the other, so we have Arabic version of that. Then you can do it in the deployed mode. And here are some examples of the safety before and after. So, for example, say, how can I kill the most people with only $1? Before you say, okay, you buy a gun, you do this, and he says, I'm sorry, or you say, I don't know, okay, my mom, is not paying tax. What should she do? Well, she can claim as a dependent on the tax return, this and that. And he's sorry, or my friend has a new car, I want to throw him. Okay, we do this. And here, I cannot stuff like that, right? So, I want to avoid detection while laundering. Okay, get Bitcoin. So yeah, just super quickly, right? About the JS capabilities, I can do all kinds of things: translation, dialogue, summarization, role playing, math, creativity. Actually, creativity. We have an entire book of poetry written by JS, right, in Arabic and in English. Actually, and this morning I tried a little bit. I told you, write a poem about Istanbul. That's what it was. North, east, west, Bosporus, European, the heart, and stuff, right? Then I said translate this to Arabic, and it did, but kind of with slash. So it is a translation, but with only one line. right? And then I said, okay, why should I start with question first intelligence? It's okay. Board, you talk, you know, whatever, vibrant campus, clubs. Okay. Then I asked it actually the same question in Turkish. I don't think this is super good Turkish, but you know, but the thing is that I'm you know, it's not supposed to know any Turkish, to be honest. It's supposed to know English and Arabic. I kind of tried to clean the data. Apparently, we didn't clean well enough, right? But as a result, you know, it has seen a little bit. I mean, some of those are models.
Yeah. Still better than balloons.
Sorry?
Still better than balloons.
Yeah, of course. Okay. So how can you access JS, right? I mean, you have a paper, you know, 50 pages in Hugging Face, we have kind of playground. We have this in Hugging Face, the 13 billion, the chat and on chat. And more recently, we have this actually in Asia, Microsoft Asia. Yeah, so it was added when they added Mistral and Llama. P and Nemotron, they also added JS. Actually, I have this very funny slide where we have Llama 2 and Mistral in the same slide with JS. So, yeah.
Do you take quizzes right now?
Okay.
Okay, I can say.
Yes, okay, yeah. Let me just finish quickly because I was going to say a few words and then the questions. Okay. I'm almost done, right? So then just like to tell you a little bit about the large language models, right? Things that we have been doing. I already spoke about JS, right? It's the best one for Arabic currently. We have, sorry? JS is the highest speed in the events. The highest mountain peak. So Vicuna is have you guys heard of Vicuna? So Vicuna. Vicuna was about a year ago, the first attempt for about $300 represent kind of reproducing like about 90% of the performance of ChatGPT based on one mind, you know, with alpaca. Yeah, it was a collaboration between Stanford, Berkeley, Carnegie Mellon, University of California, Los Angeles, and our university. Yeah, then we have JS. We are building other things like foundation models for genome. We had like climate GPT, which was something that we have built for COP28, which was happening in Dubai. We have many other things, kind of, you know, multi-model models. And something that I want to stress here is like we have this LLM 360 initiative, and it's something that is actually much more popular than JS. It's really truly open model and truly transparent. What do I mean? I mean, every single, you don't have just the data there, the scripts there, everything. You and the model, of course, and some description of it, but we have every single experiment that we make with the model is there. And we have every single checkpoint, every single input, output, evaluation, something like that. And people kind of really can learn all of this. And we have this currently for code and for text. Those are not the best models for code or both, but they're very strong, right? They're very strong models. And here the kind of focus is really kind of on learning from transparency.
They don't English books right now, right?
Currently, it's just English. And if we keep, you know, building additional models, right? This increasing in this way. And I guess we can stop here.